Hello. In this section, I will go over some basic limits involving trig, and I will go over special trig limits. So we're going to go over, just regular trig limits, and we're specifically going to go over some what's called special trig limits. So that there's three main special trig limits you should know. So go ahead and press pause if you need to write down these three rules. So the first special trig limit is limit as x approaches 0, which is sine of x over x equals 1. Now, this is equivalent to saying something like sine of 3x over 3x, right? As long as the one in the parentheses are the same. That's what that's your goal, is to make this the same. Okay, and then the other one is going to be limit as x approaches 2 of x over sine of x equals to 1. So it's like basically the reciprocal of this. So that's still 1. And then the third one is as limit as x approaches 0, 1 minus cosine of x over x equals to 0. Okay, so those are the three main special trig limits. And then if you don't know, this should be reviewed, but I'm going to review it. Tan of x is the same thing as sine x over cosine of x. Secant of x is the same thing as 1 over cosine of x. And then cotan of x is the same thing as cosine of x over sine of x. And cosecant is the same thing as 1 over sine of x. Okay, so let's do example 1. Let's find the limit as x approaches 0 of tan of x over sine of x. So the first thing before I don't even bother putting 0 into sine in the original problem, because you'll get 0. What I would do is try to simplify this. Tan of x over sine of x. So what do I know? I know that tan of x is the same thing as y over x, or sine of x over cosine of x, right? And then it's all over sine of x. Okay. So we have a complex fraction. So I'm going to use my bracket method. So on the numerator, our denominator is cosine of x, and then on my denominator is 1. So the common denominator would be cosine of x. So when I multiply cosine of x by the entire numerator, the cosine x disappears, so you're just left with sine of x. And then when you multiply cosine of x with the denominator, you're left with cosine of x times sine of x. Okay, and I noticed that sine x cancels, so you're left with 1 over cosine of x. Okay. So you can rewrite this problem as the limit as x approaches 0, 1 over cosine of x. Okay. And then just plug in your x value for 0, so 1 over cosine of 0, which is 1 over, and then the cosine of 0 is 1. So 1 over 1 is 1. Okay, so your final answer is 1. Let's move on to example 2. So we got to find the limit as x approaches 0 of tan of x over x. Well, just like the last one, I should simplify as much as I can. So I know that tan of x is the same thing as sine of x over cosine of x, all over x over 1. So I'm going to do the bracket. By the way, if you don't feel comfortable doing the bracket method, you can do it this way. You could do sine of x over cosine of x divided by x over 1. Then you can cross multiply or change this divide sign to multiplication. You would have to flip this. I'm just used to doing the bracket method. Okay, so On the numerator, our denominator is cosine of x, and then on the denominator, my denominator is 1. So my common denominator would be 1 cosine x, which is just cosine of x. So cosine x times this, the cosine x cancels, so you're left with sine of x over cosine of x times x is x times cosine of x. Okay, so let me write out the problem. So this is going to be limit as x approaches 0 of sine of x over x times cosine of x, right? Now, if you look at this problem very carefully, you see an identity, right? You see one of our trig identities. This, right? What is the limit as x approaches 0 of sine of x over x? Well, that would be 1. So this just becomes 1. So this is a number, so you could put it outside the limit. So you could say 1, and then limit of x approaches 0. And then you're left with this 1 over cosine of x. So where I put this 1, I put it in front of here. And then you're left with 1 over cosine of x. Right? And then that's going to be 1, because you got it from here, times 1 over cosine. Actually, let's, before we multiply out the 1, let's do the limit of x approaches 0 of 1 over cosine of x. So that would be 1 over cosine of 0. So that would be 1 over cosine of 0 is 1. And then you times it by this constant. So your final answer is 1. Okay. So the trick for this problem was I just used one of my trig limits and just use that from there. Let's move on to example 3. This should be the limit as x approaches 0 of sine of 2x over x. So let's see, could we simplify this any further? I don't think we can. What could we do? Well, I could use one of our trig identities, right? I mean, trig limits. So this one is very close to one of our the trig limit, right? X limit as x approaches 0 of sine of x over x. The only difference is there's a 2. Well, the key is to get this thing here as the same as this. So maybe we can make this x as 2x, right? Okay, so this is the tricky part. So if you try to make this sine of 2 of x over 2 of x, because you want this to be the same, right? You want these to be the same. I would have to multiply this by 2, and then I would also have to multiply the numerator by 2 to balance it, right? Because if I just left it as if I just left the 2 on the bottom, that actually changes the problem. But in order to balance it correctly, we can multiply the numerator by 2, or 2 over 1, right? Because guess what happens? 2 times 2, 2 divided by 2 is just 1. So it doesn't really change the equation, the problem, right? So if you do that, it satisfies this part, and then we're okay. So, okay, so now we have this. So what is the limit as x approaches 0 as of sine of 2 of x over 2 of x? Well, it's one of our trig limits, which is going to be 1. So you can replace this with 1. Since that's a constant, you can put it outside the limit. So it would be 1 of limit as x approaches 0, and then you're left with 2 over 1. Okay, so the limit of x approaches 0 of 2 over 1 is going to be just 2, and then don't forget about this 1 here. So it's 2 times 1, which is 2. Okay. Now, let's move on to example 4. So the limit of x approaches 0 of sine of x over 5 of x. So we're going to use the same trig limits of the one on, for example, 3, right? We're going to use this trig limit as x approaches 0 of sine of x over x, which is 1. But the thing is, I want these to be the same, right? I want this. So you can either factor out this 1/5, or you can just make them both sine of 5 of x over 5 of x, right? So yeah, so let's do that. So I'm gonna have to multiply this numerator by 5 in order to get 5x, right? But in order to balance it, I have to multiply the bottom as 1 over 5, because 5 times 1 over 5 is just technically 1, which doesn't really change the problem, right? So so if you're going to do this, so we'll write it out again. So it's going to be limit as x approaches 0 of sine. Now this is no longer just going to be sine of x, it's going to be sine of 5x over 5 of x times 1 over 5. Okay, so this right here becomes 1. So this just becomes 1. So you put that as a constant, so you put that in front of limit. So it's going to be 1 times the limit as x approaches 0 of, now what we're left over is 1 over 5. Okay, so the limit of x approaches 0 of 1 over 5 is just 1 over 5. Then we have to times this by 1. So 1/5 times 1 is 1 over 5. Okay, so that was example 4. Let's do example 5. So we have the limit as x approaches 0 of sine of x times 1 minus cosine of x all over 2x squared. So what should I do first? I wouldn't FOIL it out. I would not FOIL it out. That's my first instinct, but if I do FOIL it out, it would make it a lot more complex than it is. So what we'll do is just try to use what we know. So maybe we could use the trig limit, limit of x approaches 0 of sine of x over x equals to 1, right? So maybe we can what can we do? There's two things we could do. We can actually not two. There's two ways we could think of it. We can make this sine of x. We can make this right here sine of x squared over x squared, or you can rewrite that as sine of 2x squared over 2x squared, right? As long as these are the same, we're fine. So maybe we could just use this. Okay, so there's a 2 here. You know what? It doesn't really matter. What if we just make it look like this? So on the bottom, we already have 2x squared. So on the top, in order to get a 2x squared here, we need is a 2 and an extra x, right? But in order to balance it, so we don't change the problem, you would have to multiply this by 1 over 2x, because 2x times 1 over 2x is just 1, which is okay because it doesn't change the problem. Okay, so now we have limit as x approaches 0 of sine. Now this is going to be 2x squared, right? Because 2x times x is 2x squared over 2x squared times it by 1 minus cosine of x times it by 1 over 2x. Okay, so what does this become? This just becomes 1 because of this identity, right? So you could put that 1 in front of the limit, so it's 1 times limit as x approaches 0 of 1 minus cosine of x times it by 1 over 2x, right? So now let's plug in our x values. So this is going to be, on the numerator, 1 times that is just 1 minus cosine of x, right? Oops, so let's simplify over 2x. So this, you can write this as limit as x approaches 0. So that'd be 1 minus cosine of 0 over 2 times 0. This is actually what I did. I made a mistake. Maybe we should have just let's redo this again. So let me just re-erase, because what happens is we're gonna get 0 over 0, which is undetermined, not good, right? You don't want 0 over 0. So let's redo this. Well, maybe there's an easier way to erase this. Yes, good. So it's going to be limit as x approaches 0. So yeah, I'm a math tutor and I still make mistakes because I am human. So let's see here. Maybe instead of making, yeah, what I think we should do is let's make this sine of x square over x square. I think that would work. And then this 2, let's just move this 2 over here, right? Let's just move that 2 over there. Okay, so but we still want an x squared here, so we're gonna have to multiply this by x, and then to balance it, you're gonna have to multiply it by 1 over x, right? So you get limit as x approaches 0, and then this is going to be sine of x squared, right? Because x times x is x squared over x squared times this whole thing. And then this would be two x. Nope, that won't work. Okay, one more time. Okay, what if I know what I do, what I made okay, it should be limit as x approaches 0, and then it's going to be sine of x, and then this is going to be 2, and then x squared can be written as x times x. And then you have 1 minus cosine of x. So what if I made everything as sine of 2x over 2x, right? So if we do that, okay, that would mean I would have to multiply this by 2, right? And then to balance that, I would have to multiply this by 1 over 2. And then I would have to multiply. Okay, cool. So this would be limit as x approaches 0 of sine of 2x over 2x times it by 1 minus cosine of x. And then there's a 2 on the bottom here, right? Good. Okay, now we're getting there. So now this here becomes 1. So you could say, so this would be 1 times the limit as x approaches 0. And then this is going to be 1 minus cosine of x over 2. There we go. So now let's simplify this. So what is the limit of this as x approaches 0? So it'd be 1 minus cosine of 0 all over 2. And then it's going to be 1 minus cosine of 0 is 1 over 2. And then that would be 1 minus 0 is 0 over 2. And then don't forget that we have to times this by 1. So that's anything times 0 is going to be 0. So your final answer is going to be 0. Let's do example 6. So the limit as x approaches 0 of sine squared x over x. So first thing I would do is I would rewrite this problem as the limit as x approaches 0 of sine of x times sine of x, right? All over x. Now you see that we have an identity. This right here is going to equal to 1. So it's going to be 1 times the limit as x approaches 0 of sine of x. Okay. So go ahead and figure out what is the limit as x approaches 0 of sine of x. That's just going to be sine of 0, which is going to be 0. And then you have to times this by 1. So 0 times 1 is 0. Wow, a lot of zeros. Let's do example 7. How much? Example 7, example 8. Okay, 3 more problems. So Example 7 says limit as h approaches 0 of 1 minus cosh, that's not cosine, cosh square all over h. So what I would do is rewrite the problem. Limit of h approaches 0 on the new, so this part here can be written as 1 minus cosine of h times 1 minus cosine of h all over h. Now, can we use one of our identities? Yes, we can. We have the this identity limit as h approaches 0 of 1 minus cosh all over h. That becomes 0. Okay, so that's, you can put that 0 in front of limit, but you know anything times 0 is going to be zeros, but let's just try it. Let's just finish it anyway. So this is going to be limit as h approaches 0 of 1 minus cosh. So that's going to be 1 minus cosine or cosh of 0. So that's going to be 1 minus cosine of 0 is 1. So that's going to be 0. And then you have to times this by 0. So 0 times 0 is 0. Okay. Example 8. Okay. So this is actually, the final answer is not going to be 0, so good. So we have the limit as x approaches pi over 2 of cosine of x over cotan of x. So the first thing is simplify, right? So I can simplify this as cosine of x over cotan of x in terms of sine and cosine would be x over y, or cosine of x over sine of x. Okay, so we have a complex fraction. So this cosine of is the same thing as cosine of x over 1. So we have a denominator of 1 on the numerator, and then on the denominator, we have a denominator of sine of x. So the common denominator would be sine of x. So sine of x times cosine of x is sine of x times cosine of x over sine of x times this. The sine of x cancels, so you're left with cosine of x. So the cosine x cancels, so you're left with sine of x. So it's going to be the limit as x approaches pi over 2 of sine of x. So that's going to be sine of pi over 2. And we know that the sine of pi over 2 is just 1. One more problem, and then we're done. So sine of the limit as t approaches 0 of sine of 3t over 2t. So what shall we do? Well, maybe we can make this the sine of 6t over 6t, right? So that can be equal to 1. So okay, so over here, if we want to make this 6t on the numerator, we have to multiply this by 2. Then to balance it, we have to multiply it by 1 over 2, because that doesn't change the problem. It's almost like multiplying it by 1, right? Okay, and then over here, in order for this 2 on the bottom right here, to make this 6, we're gonna have to multiply this by 3. But to balance it, you're gonna have to multiply this side by 3 over 1. Okay, so we get limit as t approaches 0 of sine of 6t over 6t times it by 2 times 1 times 3, that's 6 over 2. Okay, so we know that this right here just becomes 1. So it's going to be 1 times the limit as t approaches 0 of 6 over 2. So the limit of t as approaches 0 of 6 over 2 is just going to be 3. Actually, it should be 3. Let's see. Let me do my CMO. So I multiply this by 2, so that'd be, and then I had to multiply this by 1/2. Good. Then I had to multiply this by 3. Oh, I see. And then I actually had to multiply this by 3 over 3, right? Because if I just multiplied by 3, that does change the problem. So it's actually 3 over 3, which is the same thing as 1, right? Okay. So when you do that, that's going to be 2 times 3, that's 6. And then it should actually be 6 over 2 is 3. It should be 3 over 2. Oh, okay. It's hard to see. Okay. So that when we multiply this by 2, this is going to be 6t. And then here you're going to multiply this by 3. Yeah. It's a little bit tricky to make a mistake. So yeah, let me do this problem again to show you what I mean. So we were right the first time. We were right trying to make this sine of 6t over 6t. So to do this, to multiply this to get 6, you have to multiply this by 2. But then to balance it, you have to multiply this by 1 over 2. And then over here, to make this a 6, you would have to multiply this by 3. And in order to do that, you have to multiply this by 3 over 1. There you go. So this becomes limit as t approaches 0 of sine of 6t, right? Because 2 times 3 is 6t, over 3 times 2 is 6t, times, now, be careful. So you put this here and put that there. So you're left with 1 times 3. Yeah, so that the mistake is what I did was I multiplied all out. So no, this 2 goes with this 3t, so that's 6t, and then this 3 goes with 2t, so that's 6t. So we're left with 1 over 2 and 3 over 1. So we know that this becomes 1. So it's 1 times the limit as t approaches 0. And you're left with 1/2 times 3 over 2 is 3 over 2. So what is the limit as t approaches 3 over 2? It's just 3 over 2, and then times it by 1. And you have your final answer is 3/2. So that is your final answer. Okay, that wraps it up for this section. Thank you. Have a good day. Bye-bye.